Hello everyone, in this video I'm going to discuss example for limits, horizontal asymptote, vertical asymptote, and also the continuity. Given we have the situation fx, so find the limits appropriate point, obtain the vertical and horizontal asymptote. So let's say we're including the graph sketching as well for these questions. So currently referring to the question, we may express the fx. For example, we have the square root x minus 3 over, we have the x minus the 4. So by referring to the situation above, here we have the domain x is greater equals to 3. For the bottom part, we have negative infinity until we have the 0, union 0 until the 4, and then from the 4 we have until infinity. So try to imagine greater than 3. So meaning that focus on this part. So number 1, the domain for the f would be start from 3 until 4, union 4 until infinity. So that is the first step for the domain. Second step is to find the x-y intercept. In order to find the x-intercept, y must be equals to 0. So from here, x is equals to 3. So we have 3, 0 for the x-intercept. Then for the y-intercept means that when x equals to 0. Currently refers to the domain. We notice that when x is equals to 0, there is no graph. So we can say it does not exist. Step number 3, focus on the vertical asymptote. So in here, we are focusing on the situation. So when x is equals to 3 and also x is equals to 4. So limit when x approaching 3 from the left, limit when x approaching 3 from the right. Limit when x approaching 4 from the left, limit when x approaching 4 from the right. So can you substitute the function? So by referring to the calculator, we may substitute the value. Let's say 3 from the left, we have 2.999. From the right, we have 3.001. If for the 4, we may have 3.999 and 4.0001. Kindly substitute and we notice that we have undefined, does not exist for the left hand side. You may refer to the domain where from the left of the 3, there is no graph. So if we substitute 3 from the right, the value of y will be approaching 0. So it's not vertical asymptote because there is a value. Continue. If we substitute 4 from the left, we will obtain the situation. If we refer to the situation here, then we will have negative infinity, means that decreasing. For the right hand side, we will have positive infinity. So from here, the vertical asymptote where we have x is equals to 4. So vertical asymptote x is equals to 4. Whereas for the 3 is not vertical asymptote. Next, limit for step number 4 is to find the horizontal. When x approaching negative infinity, for the situation square root x minus the 3 over x square minus the 4. If we refer to the domain, actually there is no graph. So we can say it does not exist. Limit when x approaching the positive infinity. So in here, we have to factor out the x square. So based on the situation, we have square root x to the power 4 because in order to obtain the x square, so here will be 1 over x to the power 3 minus 3 over x to the power 4. Over, we have the x square, then we have 1 minus 4 over x square. Rewrite the situation, limit when x approaching positive infinity. So here we will have x square, bracket, 1 over x to the power 3 minus 3 over x to the power 4. Over, we have the x square, 1 minus 4 over x square. So if we simplify, we will obtain 0 over here, 0 over here, 0 over here. So at the end, we will have the value 0. So it means that the horizontal asymptote y is equals to 0. So continue. Let's say we want to sketch the graph. Okay, Kali refers to the xy axis. So refers to step number 1. We have 3 and also 4. Let's say 1, 2, 3 and then 4. So continue. We have the situation 3, 0. So here let's say we have the 3, 0. Then continue. We have the vertical asymptote when x is equals to 4. So 4 from the left, we will have negative infinity. 4 from the right, we will have positive infinity. Next, we have the horizontal asymptote where y is equals to 0. Then they were approaching 0 from more than 0 or less than 0. If we substitute by using the calculator x, which is equals to 50, and we will have the value more than 0. So the graph will be something like this. Another one, the graph will be approaching something like this. So that is the graph for the fx. Next kindly refers to b. Given we have the piecewise function, so my suggestion is to illustrate the situation in a real number line. So here we have the q, then here we have the 2. Less than q, we will have 2 minus the x bracket square minus the p over x. If for the q and 2, then we have r bracket x plus with the 6. If it's a q, so we will make use of this function. We have x cubed minus p. If it's a 2, we will make use of this function, x cubed minus p. Kindly refers to the question. Find the value of p and q and also the r such that f is continuous everywhere, and we have fp and we have f2 which is equals to p. Now we are focusing on the q. Number 1, limit when x approaching q from the left. We have the function 2 minus x bracket square minus the p over x equals to limit when x approaching q from the right, and we will have the function r x plus with the 6. So kindly substitute the q, so we will have 2 minus the q bracket square minus the p over the q equals to, we have r bracket q plus with the 6. We have the situation p, q and r. Next, let's say we focus on the 2 first. So as we all know, f2 which is equals to p. Then focus on the situation. If we substitute the 2, then we will have p which is equals to 8 minus the p. So 2p which is equals to 8, p which is equals to 4. So that is the value p equals to 4. Continue. Limit when x approaching 2 from the left, we have r bracket x plus with the 6 equals to limit when x approaching 2 from the right, then we have the situation x to the power of 3 minus the 4 because p which is equals to 4. If we substitute, and we will have r and then 8r equals to, we have 4. So r is equals to 1 over 2. So now we have p equals to 4, r equals to 1 over 2. Kindly substitute. So we have 2 minus the q bracket square minus the 4 for the p, and then we have the q equals to, we have 1 over 2 for the r, so we will have q over 2 plus with the 3. So rearrange the situation. So we have 2 minus the q bracket square minus the 4 equals to, we have the q squared over the 2 plus with the 3q. Continue. Expand the situation. We have 4 minus the 4q plus with the q squared minus with the 4. From here, we have q squared minus the 4q equals to, we have the q squared over the 2 plus with the 3q. Multiply all the term with the 2. So we have 2q squared minus, we have 8q, and then equals to q squared, and then plus with the 6q. So we have the q squared minus the 14q which is equals to 0. Q bracket, we have q minus the 14 equals to 0. So the q will be equals to 0 and the q which is equals to 14. So based on the number line, the q would not be 14 because it must be less than 2. So q is equals to 0 would be the situation. So p equals to 4 and then r equals to 1 over 2, and then the q must be less than 2. So this one is not valid, but valid for q which is equals to 0. So finally, we have the q equals to 0.
Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.